You know, we all use databases. They're the engine behind basically every app we build. But let me ask you this. Are you building your databases to really perform and scale, or are you just kind of getting them to work for now? Today, we're going to change that. We're going on a journey from some of the most common design mistakes to what I'd call true database mastery, all focused on building rock-solid, super-fast systems with PostgreSQL.
All right, let's just jump right in with a question that, honestly, every single developer should be asking themselves. Is your database helping you, or is it secretly hurting you? Is it a silent performance killer, or is it the solid foundation of your whole application? And here's the kicker. The answer usually isn't about buying faster hardware. Nope, it's almost always about how it was designed right from the very beginning.
So first up, let's talk about what not to do. And believe me, it is shockingly easy for everyone, even seasoned pros, to fall into these traps. We're talking about anti-patterns. You know, those things that seem like a convenient shortcut at first, but then, boom, you're stuck with massive technical debt and some real performance nightmares down the line.
Okay, check this out. This slide is a perfect tale of two models. On the left, you've got the infamous EAV model. That's entity attribute value. And hey, it looks super flexible, right? You can just throw anything you want in there. But then look at the right. That's a properly structured type-safe model where every piece of data has its correct type. The difference between these two in terms of reliability, it's literally night and day.
And here's the train wreck. Here's why EAV is just so bad. Everything, and I mean everything, gets stored as text. You lose all data integrity. You need to store a number. Too bad, it's text now. A date? Also text. And what happens when someone makes a simple typo in a parameter name? Poof! You've just created phantom data that your application will never, ever find. And trying to get data back out? A simple lookup turns into this horrible mess of complex joins, and your whole query can just crash if it tries to convert some text that isn't what it expects.
And this quote, this is just perfect. It nails another huge sin in database design. You know, when we try to be a little too clever for our own good, we've all been tempted to do it. Just stuff a bunch of values, like a list of tags or something, into a single column, maybe separated by commas. It feels efficient, right? But as the legend Donald Knuth said, this kind of premature optimization, it's the root of all evil. It makes searching, running reports, and just general maintenance a complete nightmare.
Okay, enough of the horror stories. We've seen the pitfalls. Now let's talk about building a solid foundation. How do we actually avoid these problems from day one? Well, it all boils down to a few core bedrock principles of good database design. So the first big one, and you could argue it's the most important, is normalization. And look, it sounds like a scary academic word, but it's not. It's really just a simple, systematic way of organizing your data to get rid of repetition and make sure everything is stored in a logical place. It's the absolute foundation for building a database that's sane, easy to maintain, and actually reliable.
And every good relational database, like Postgres, makes a promise to you. It's a guarantee. And it's called ACID. A is for atomic, all or nothing. A transaction either fully succeeds or it completely fails and rolls back. C is for consistent. Your data rules, your constraints, they are never ever broken. I is for isolated. If you have a bunch of transactions happening at once, they won't step on each other's toes and corrupt the data. And D is for durable. Once you commit a change, it's there to stay, even if the power goes out. For any serious app, these are totally non-negotiable.
Okay, so let's say you've done it. You've got a solid, normalized design. Awesome. But how do you make sure it stays fast when you start throwing millions of rows at it? Well, this is where we get to shift from theory into practice. Let's look at the tools that help us hunt down and fix those real-world performance bottlenecks.
And in the world of PostgreSQL, your number one tool, your superpower, is Explain Analyze. I want you to think of this like an X-ray for your SQL queries. It doesn't just give you the answer. No, it shows you the exact plan the database used to get that answer, step by step. It'll show you where you're doing slow table scans, where your joins are inefficient, all the hidden problems. Seriously, every single performance tuning journey starts right here.
Let's see just how powerful this is. We're looking at a real-world test here. It's a table with 100 million rows. 100 million! And we're just doing a simple lookup for one record using its UI ID. Without an index, look at that time. Almost 13 seconds. In the world of web applications, 13 seconds isn't just slow. It's an eternity. It's user close the tab slow.
Okay, but now, watch this. We add one simple thing, the right kind of index. In this case, it's a hash index, which is tailor-made for these exact match lookups. In the query time, it just plummets. We're now down to under 11 milliseconds. That's not just an improvement. That is a completely different universe of performance.
I mean, just look at the difference here. The impact is absolutely staggering. We're talking about a speed up of over 1,000 times, 1,185x faster. We went from I'm going to go make a coffee while this loads to blink and you miss it instantaneous. That is the raw power of using the right index for the right job.
But, okay, what happens when you keep growing? When millions of rows turn into billions of rows? At that point, even with perfect indexes, you could start hitting some new and interesting bottlenecks. So the next tool we need to pull out of our toolbox is designed for exactly that kind of massive, massive scale.
And that solution is called table partitioning. The idea is simple but brilliant. Instead of having one single massive monstrous table, you actually split it up physically into smaller, more manageable pieces. The filing cabinet analogy is perfect. Instead of one giant pile of papers on the floor, you have a neatly organized cabinet. So when a query comes in, Postgres is smart enough to know, aha, I only need to look in this specific drawer, and it can completely ignore all the others.
And what's cool is that PostgreSQL gives you a few different ways to slice up your data. You can partition by a range of values, think dates. So you'd have a partition for January, one for February, and so on. That's amazing for time series data. Or you can partition by a list of specific values. This is great for things like geographic regions, a partition for North America, one for Europe, etc. And finally, there's hash partitioning, which basically just spreads the data out evenly, which is great for balancing the load.
So we've covered good design, we've covered performance tuning, and we've covered scaling into the billions. But you know what? The game is changing yet again. For decades, there's been this big wall, this great divide in the database world. On one side, you had your OLTP databases, built for fast, day-to-day transactions. And on the other side, you had your OLAP databases, built for running big, heavy analytical queries.
And the trade-off was always a painful one. To get those super-fast analytical queries, you'd use something called a columnar format. It's great for analytics, but it usually meant you had to give up on those lightning-fast lookups for a single record that we just talked about. You had to choose fast transactions or fast analytics. You couldn't have both. Well, until now, because that wall is starting to crumble.
And this is where it all comes together. We're seeing modern extensions for PostgreSQL, like Timescale DB, that are doing something amazing. They're making it possible for standard indexes, the same ones we just used, to work directly on that compressed, analytical columnar data. So remember that incredible 1,185 times speedup we saw? Imagine getting that kind of performance, but on your analytical data. You get the best of both worlds. This isn't just an improvement, it's a huge leap forward.
So, let's stop thinking about our database as just some dumb container for our data. It's so much more than that. When you combine the right design principles from the start, use the right tools to keep it fast, and really understand what's possible today, it transforms. It goes from being a potential bottleneck to being a powerful, scalable, competitive edge for your entire application. The only question you have to ask yourself is, which one is yours?